10th class state syllabus exercise 10.3 question number 1. An iron pillar consists of cylindrical portion of 2.8 meters height and 20 centimeters in diameter and a cone of 42 centimeters height surmounting it. Find the weight of the pillar if 1 centimeter cube of iron weighs 7.5 grams. This is the pillar of iron. Its cylindrical portion, that is 2.8 meters, and the this height, that means height, and 20 centimeters in diameter. Diameter is 20 centimeters, that means 10 centimeters radius, and cone is 42 centimeters height. So we need to find the volume of these, total volume of this iron pillar. That means the volume of the iron pillar is the sum of volume of the cylinder and the volume of the cone. The volume of the iron pillar is volume of the cylinder plus volume of the cone. And the radius of this cone and cylinder is same. That is, diameter is given, d is equal to diameter d equal to 20 centimeters. So r equal to 20 by 2 equal to 10 centimeters. This is 10 centimeters. Now the radius is r equal to 10 centimeters and height h is equal to 2.8 meters, that equal to 2.8 into 100, because here centimeters is there, we should change this meters into centimeters. Multiply with 100, we will get in centimeters, that equal to 280 centimeters. 280 centimeters. The volume of cylinder volume of cylinder V is equal to pi r square h. This equal to 22 by 7 into r square is equal to 10 square. That means 10 into 10. The height of the cylinder is 280. 280. 7 4s are 28. 0 cancelled. Therefore, this equal to 22 into 4 is 88 and 3 zeros are there. This equal to 88,000 88,000 cubic centimeters, that means centimeter cube. This is the volume of cylinder, and we need to find the volume of the cone. Volume of the cone. The volume of the cone. Height of the cone is 42 centimeters and the diameter is same, that is 10 centimeters here. The volume of the cone is 1 by 3 pi r square h. This equal to 1 by 3 into pi equal to 22 by 7, and r is common for both cylinder and the cone, 10 centimeters. R square is 10 into 10, and height of this cone is 42 centimeters. Now 7 6 42 cancel. This equal to 3 2 6 cancel. 2 into 22 4400 centimeter cube. The volume of the cone is 4400 centimeter cube and the volume of the cylinder is 88,000 centimeter cube. The total volume of the iron pillar is 88,000 plus 4400. The total volume of the pillar is volume of the cylinder plus volume of the cone. The volume of the cylinder is 88,000 plus volume of the cone is 4400. This equal to 004 and 412 9 is equal to 92,400 centimeter cube. The total volume of the pillar is 92,400 centimeter cube. Now the weight, we should find the weight from the question. The pillar 1 centimeter cube of iron weighs 7.5 kg. 1 centimeter cube weighs 7.5 grams. 1 centimeter cube equal to 7.5 grams weight is there. Grams 7.5 grams. But here how many centimeters cube volume is there? 92,400. That means the weight of the pillar equal to weight of the pillar equal to 92,400 into, for 1 centimeter cube you have 7.5 grams. This equal to, multiplying with 7.5 is a 1 by 3 by 4th, this is equal to 60 693,000 grams. 693 grams weight is there. That means we want to change into kgs. We should divide with 1000 by 1000 by 1000. We will get in kgs. Three zeros cancelled. Therefore, this equal to 693 kgs. 693 kgs. Kgs. So the weight of the pillar is 693 kgs. A toy is made in the form of a hemisphere surmounted by a right cone whose circular base is joined with the plane surface area of the hemisphere. The radius of the base of the cone is 7 centimeter and its volume is 3 by 2 of the hemisphere. Calculate the height of the cone and the surface area of the toy correct to two decimal places. This is a cone is surmounted on hemisphere with radius is 7 centimeters. This is 7 centimeters radius is there, and height of this cone is we need to find. Here given the its volume, that means cone volume of the cone is 3 by 2 times of hemisphere, the volume of hemisphere. That means volume of the cone is 3 by 2 times of volume of the hemisphere. Hemisphere. That equal to volume of the cone is 1 by 3 pi r square h equal to 3 by 2 into volume of the hemisphere. The volume of the hemisphere is 3 by 2 into hemisphere is 2 by 3 pi r cube. 2 by 3 pi r cube. Here 2 get cancelled. 2 cancelled. 3 also cancelled. And both sides pi cancelled. Here r square is cancelled. Here only r is there. So that equal to 1 by 3 h is equal to r. 1 by 3 h is equal to r, where h is equal to 3r. That means h is equal to 3r. R is given, we know that, but r equal to 7. Then h is equal to 3 into 7 is equal to 21 centimeters. So the height of the cone is 21 centimeters. And calculate the height of the height is 21 centimeters and the cone, the surface area of the toy. We need to find this surface area of the toy. Surface area of the toy is curved surface area of this cone and curved surface area of this hemisphere. Surface area of the toy is curved surface area of the cone plus curved surface area of the hemisphere. That equal to curved surface area of the cone is pi or L. We need to find that L square is equal to, we know that 7 square h square plus r square, that is 7 h square plus r square, that is 7 square plus 21 square, r square plus h square, you can take any, 49 plus 21 ja 21, 21 ja 441, this equal to 490, 490, then the L is equal to, approximately we will get 22.135 centimeters. This is L. Now the curved surface area of the cone is pi RL, and the curved surface area of the hemisphere is 2 pi r square. 2 pi r square is equal to pi RL means 22 by 7, r equal to 7, and L equal to 22.135 plus, and the curved surface area of this hemisphere is 2 into 22 by 7 into r square is 7 square, that is 7 into 7, and here 7 7 get cancelled, and here also 7 and 7 get cancelled. This equal to 22 into 22.135 equal to 486.99, 486.99 plus 22 into 22, 44 into 7, 4 is 28 and 2 30, 380. Therefore, this equal to 486.99 plus 308 is equal to 794.99 centimeter cube. Yeah, this is already here. Correct the toy surface area equal to centimeter square area, centimeter square. Correct the toy surface area up to 2 decimals, means here is 2 decimals are there, 794.99 centimeter square. This is the surface area of the toy. Find the volume of the largest right circular cone that can be cut out of a cube whose edge is 7 centimeter. The radius of the cone with the largest volume that can be cut out from a cube, its edge is 7 centimeters. It's a cone cut out of this cube. Now look at here. This is the cone touches this edges. That means edges with the 7 centimeters. So the radius of this cone is 7 by 2, 7 by 2, and its edge is 7 centimeters, 7 centimeters. Find the volume of largest right circular cone. Here is a cone is there, but the height of this cone is also, and it is the top of cube side. So from here to here, the height of the cube both are same. So now the radius is 7 by 2, height of this cone is 7 centimeters, 7 centimeters, and 7 by 2 is the radius. And we need to find that uh, volume of cone, equal to, what is that, 1 by 3 pi r square h, 1 by third of pi r square h. So this equal to 1 by 3 into pi equal to 22 by 7, and r is 7 by 2 into 7 by 2, 7 by 2 into 7 by 2, and h equal to 7. So now this 7 get cancelled, and 2 11s are 22, that equal to, here 11 into 7 into 7 by 6 by 3 into 2, 6. This equal to 7 into 7, 49 into 11. This equal to 539 by 6 by 6 is equal to 6 8s are 49, 6 8s are 49, and 6 49 remaining 59, 6 9s are 54, and remaining 5 is there, 6 8s are 48, and 6 3s are 18. This equal to 89.83 centimeter cube. The volume of the cone is 89.83 centimeter cube. A cylindrical tub of radius 5 centimeters and height 9.8 centimeters is full of water. A solid in the form of right circular cone mounted on a hemisphere is immersed into the tub. The radius of the hemisphere is 3.5 centimeters and height of the conical pot is 5 centimeters. Find the volume of water left in the tub. This is a cylindrical tub radius with 5 centimeters radius, and the height is 9.8 centimeters, full of water. The solid in the form of right circular cone is mounted on a hemisphere immersed into the top. The radius of the hemisphere is also is 3.5. Height of the conical pot is 5 centimeters. That circular cone is mounted on hemisphere and is immersed in the top. That means there is a, here is the cone, it is mounted on a hemisphere. Uh, this is with a radius of 3.5 centimeters, and it is immersed in this water, and then the water will left from this tub. And how much water is mm, mm, uh, taken out from this tub is we need to find. And now look at here, the it is full of water. Full of water means the volume of the cylinder we need to find. The volume of the cylinder is by r square h. This equal to 22 by 7. R is 5 into 5. Height is 9.8. So 7, this equal to multiply 5, 25, 22 and 9.8 equal to 5390 by 7. This equal to 770 centimeter cube. 770 centimeter cube water is there in this tub. And now we need to find the this volume of the cone and the volume of hemisphere. Now this hemisphere r equal to radius r equal to 3.5 centimeters hemisphere. So this volume equal to volume of the hemisphere is 2 by 3 pi r cube. 2 by 3 pi r cube. This equal to 2 by 3 into 22 by 7 into r equal to 3.5 into 3.5 into 3.5. 7 5 cancel. 0.5 times is 7 is 3.5. This is equal to, we will get 269.5 by 3 is equal to 3 8s are 24, 3 9s are 27, 3 8s are 24, and 1 is there, 3 3s are centimeter cube. This is the volume of hemisphere. We need to find the cone. Volume of the cone equal to, r is given, that is 3.5 centimeters are equal to 3.5 centimeters, and h equal to the height of the conical pot is 5 centimeters. H is equal to 5 centimeters. Then the volume of the cone is 1 by 3 pi r square h. V is equal to V equal to 1 by 3 pi r square h. Therefore, this equal to 1 by 3 pi equal to 22 by 7 and r equal to 3.5 into 3.5 and h equal to 5. So here 7 0.5 times cancelled, and 3 this equal to total, multiply with this 192.5 by 3 by 3, that equal to 3 8s are 3 8s are no 3 6 are 18, and 3 4s are 12.3 2 4s are 12.3 1s are 3 and 3 6 18 and 3 6 18. This equal to 64.167 centimeter cube. This is the cone volume of the cone, and hemisphere volume is 89.83, and the total volume is 770 centimeter cube. The water is there in the top, and this item is immersed in the top. So that means the volume of the solid, this solid is the total volume equal to 89.83 plus 64.167 equal to, so it is also 167 means, so take adjust 2 decimals, we will get 7, this equal get 7, this equal to, we will get 153.9, that means 154 centimeter cube, 154 centimeter cube. Here now this amount of volume of the solid is immersed in the top, then it replaces the water uh, in the tub is, then the volume of the water replaced 154 centimeter cube, then the water left in the tub, the water left in the tub left in the tub, because This the 154 centimeter cube water replaced in the tub. Then because the water is full in the tub, the water is left from the tub is equal to 770 centimeter cube water is there, and this item is replaced in the water 154 centimeter cube. Then this equal to the left water is 616 centimeter cube water. This water is left in the tub now. In the adjacent figure, the height of a solid cylinder 10 centimeters and diameter is 7 centimeters. Two equal conical holes of a radius 3 centimeters and 4 centimeters are cut off as shown in the figure. Find the volume of the remaining solid. Now look at here. The volume of the remaining solid is the volume of given solid, this total one, and here the two holes are there and its volume of conical holes. Here one, this is the conical hole, here it is also conical hole. So its diameter is given 3 centimeters, height is 4 centimeters, and this one is also same. The height of the cylinder is 10 centimeters and diameter is 7 centimeters. The volume of the cylinder is pi r square h. This equal to pi is 22 by 7, pi is 22 by 7, and r square means the diameter is 7 centimeters. This is the diameter 7 centimeters, and half of this 7 by 2, this is r. 7 by 2 into 7 by 2, this is r square, into h is equal to 10 centimeters. 7 7 get cancelled, and 2 11s are 22, 2 5s are 10, is equal to remaining 11 into 7 into 5, 55 into 11 into 5, 55 into 7 equal to 385 centimeter cube. This is the volume of the cylinder, and we need to find this conical holes. Two conical holes are there. The volume of the cylinder is pi r square h, pi equal to 22 by 7 into 7 by 2 into 7 by 2 r square, and h is 10. 7 get cancelled, 2 11s are 22 and 2 5s are 10. This equal to 11 into 7 into 5, 385 centimeter cube. This is the volume of cylinder. And volume of two conical holes is 2 into 1 by 3 pi r square h. Conical volume is cone volume is 1 by 3 pi r square h. The two conicals are there into 2, and 2 into 1 by 3, 2 by 3, pi equal to 22 by 7, r equal to 3 is given, and h equal to 4. Now substitute these values here, and 2 into 3 get cancelled, and 2 into 22 44 into 3 into 4 is 12. 12 into 44 equal to 264 by 7. 2 into 22 44 into 3 into 12, this equal to 528 by 7. This equal to 7 sevens of 49, and remaining it 49, and 2 is that 21, 3 7 5 is 35, and remaining 3 is there, that equal to 7 4 is 28, and 2 is there, 7 2 is 4 49, 6 is there, 7 9 is 75.429. Then the remaining volume of that solid, the cylinder remaining volume equal to the volume of cylinder minus 2 volume of 2 conical holes. This equal to volume of the cylinder is 385 centimeter cube, and 2 conical holes volume is 75.429. This equal to 309.571 centimeter cube. Spherical marbles of diameter 1.4 centimeter are dropped into a cylindrical beaker of diameter 7 centimeter, which contains some water. Find the number of marbles that should be dropped into the beaker so that water level rises by 5.6 centimeters. This is a question. Now, here this is a cylindrical, yeah, some water is there. Its diameter is 7 centimeters, and here dropped some marbles. Here water is there. Yeah, and dropped some marbles. Some marbles are there, and these are spherical marbles. Spherical marbles. Yeah, its diameter is 1.4 centimeter. 1.4 centimeter diameter is there. and find the number of marbles. How many marbles are dropped in this cylindrical beaker to rise this water level 5.6 centimeters. The radius of this cylinder is, because diameter is given, cylindrical beaker, cylindrical beaker dia equal to 7 centimeters, then radius equal to 7 by 2 centimeters, and height of the uh, rising water, and the rising water level is there 5.6 from here to here. This is the height of the water when the marble dropped into that beaker. So now volume of this rising water that level volume of is equal to, that pi r square h, pi r square h. Here the value of pi equal to 22 by 7 into r square equal to 7 by 2 into 7 by 2, r equal to 7 by 2, and h is there 5.6 when the water rises. Now this 1 by 2, 5.6, 7 by 2 into 5.6, this equal to 7 8s are 0.8 times is 5.6. So now 2 11s are 22, and 2 0.4 times is 0.8. So now 11 into 7 into 7 into 0.4, 11 into 7 7 is 49 into 0.4, this equal to 0.4 times, yeah, 215.6 centimeter cube. This is the water level rise by 5. At the volume at 5.6 when the water rises. Now we need to find that spherical marble is there. The volume of this marble, volume of marble equal to 4 by 3, because it is a spherical shape, 4 by 3 pi r cube, 4 by 3 pi r cube. This equal to 4 by 3 into 22 by 7 into the volume of the radius of this marble is, the diameter is 1.4, the dia is 1.4, d is equal to 1.4, then r equal to 0.7 centimeters, 0.7 centimeter cube. Therefore this equal to 4 by 3 into 22 by 7 into 0.73 times. 0.7, 0.1 times is cancelled, and this equal to 4 into 22, 7 into 7, 0.49, 0.049, and 0.1, 22 into 4 is equal to, we will get 1.437, 1.4373 centimeter cube. This is one volume of one marble. But how many marbles are required to equal this volume? That means number of marbles we don't know. Then take x, number of marbles, is x. Then one marble is 1.4373 and x marbles volume is equal to this, and x into 1.4373 is equal to x into 1.4, this volume is equal to that water volume 215.6, then x equal to 215.6 by 1.4373, this equal to, we will get 150 marbles. The number of marbles is now required 150. A pen stand is made of wood in the shape of cuboid with three conical depressions to hold the pens. The dimensions of the cuboid are 15 centimeters by 10 centimeters by 3.5 centimeters. The radius of each of the depression is 0.5 centimeters and the depth is 1.4 centimeter. Find the volume of wood in the entire stand. This is the pen stand. It has 3 walls, and like it is a cuboid, like a cuboid, and it has 3 walls. This volume of cuboid is and 3 dimensions are given, 15, 10 and 3.5 centimeter, and this depression is 0.5 and depth is 1.4 centimeters. Now we need to find the volume of cuboid is volume of cuboid equal to LBH that equal to L equal to, we know that length of the cuboid L equal to 15 centimeters and breadth of the cuboid B is equal to 10 centimeters and height of the cuboid H is equal to 3.5 centimeters. Now this equal to 15 into 10 into 3.5. This is equal to 15 into 10 into 3.5 is 35. 15 into 35 is 525 centimeter cube. This is the volume of cuboid. And the depression is the radius of each depression is given, that is 0.5. 0.5 radius of the depression is equal to uh, equal to 0.5 is there, 5 centimeters, and its depth is 1.4. That means depth that is height is equal to 1.4 centimeters. Now the volume of each depression, here 3 are there. So 3 into 3 volumes is equal to 3 into 1 by 3. It's like 1 by 3 pi r square h. So this equal to 3 get cancelled. 3 depressions volume this is. So pi equal to 22 by 7, and r square is 0.5 into 0.5. The depth is 1.4 centimeters. So this equal to 7. 0.2 times is 1.4, 0.5, 0.5, 0.25 into 22, that equal to, we will get 1.1 centimeter cube. This is that 3 depressions volume is 1.1 centimeter cube, and the cuboid volume is given 5. Already we found that 525 centimeters cube. Therefore the volume of wood is the volume of wood equal to 525 minus 1.1. This equal to 523.9 centimeter cube. 523.9 centimeter cube.